Hello my dear students, and welcome once again to another video for our class in data structures and algorithms. In this video we are going to demonstrate how to write a very simple linked list implementation of a queue data structure. First, we are going to of course create the node. Since we are going to have a linked list implementation of a queue, the first thing we need to do is the node. And this node is of course going to have a next, and this implementation will just use int as a data. So in our node we'll have int as the content or the data, and we'll have a constructor. We'll just generate the constructor, and then we'll also generate setters and getters for this, for both next and data. So that will be it for our node. The most important thing here is really the actual implementation. So here we are going to add in another file, a new file. Is going to be int q, and which will have in a queue abstract data type we have some properties, which is one, the front which is the first one in the queue, and then the other one is the back, which is the last one in the queue. And of course we'll also have another property called the size, which will be the number of items in the queue. So let's do have that. Of course both the front and back are both nodes, and we'll have an int as our size. And we'll just have a default constructor for this without anything inside, and this will simply be initializing both front and back with a null value, and of course the size starts at 0. Now the first method we're going to add here is of course the method for adding in an item into the queue, and that is in the queue abstract data type. That method is called enqueue. So say public void enqueue, and of course we enqueue the data, which is an int. Now just like in linked list, we have two possibilities of adding into a queue. Since this is a linked list implementation, we will be adding on an empty queue. We can also be adding on a queue with existing contents. So for the case wherein the queue is empty, which is when the front is equal to null, what we can simply do is assign the front, both the front and the back, with that new node having the value of having that data, and of course the next would be null. However, if it is not empty, what's wrong with this node? Oh, we have to start with the next based on our definition. So null data. Okay. However, if the queue is not empty, we will be adding the an item into the queue, or at the tail or at the back. Okay, because in the queue abstract data type, the adding is on the tail, and getting the data is on the front. So this will be just like add to tail in linked list. So we're going to have the back dot set next will have our new node have with the next as a null, and the data is of course the data, and that will be our next back. So back is equal to back dot get next. Okay, so that's how enqueue is simply written on. Now let's have removal of an item from a queue, and that is called dequeue. So public, and since we are going to get a data, we are going to return something, and that something is the type of data that we have, which is int. So we say dequeue. Alright. Now, of course, we cannot dequeue if it's empty. So we'll just have this throw a exception in case we are dequeuing on an empty queue, because we're not supposed to dequeue on an empty queue. So if front is equal to null, which simply means that our queue is empty, then we are going to throw new exception. The queue is actually empty. Otherwise, we can actually now do a dequeue. So in the dequeue, we are simply going to get the value from the top. So let's first have a reference to the front. That's the top. And then make the front go to the next of the front. And then let's just detach the n, which was previously the front, by removing the next. So n dot set next, setting it into null, and then we are going to simply now return n dot get data. Of course, since we do have a size property, when we enqueue, we are supposed to increment the size, and when we dequeue, we're supposed also to decrement the size, just like that. Okay. Now let's have a method that is going to display the contents of our queue. Let's just call this show public. Of course, this is a void method. Alright, so just have to traverse, just like in a regular linked list. You have a node equals the front, while that is not null, and we move to the next. So just like in a linked list. Now, if this is not equal to the front, we'll just add some kind of an arrow. And here, display the actual data, which is tmp.get data, and of course it should be just a print. Okay, and at the end we'll also just put a blank line. Alright, I think that would be it. So now let's create another class which will be our main, so that we can demonstrate the use of our new int queue. So just call this int queue demo, and this will of course have a main method. So we'll have an int queue, and we'll just enqueue, say 6, 90, 600, 78, and 43. Let's try to show that one, and then from this moment on, we are going to dequeue them one by one. So we have, since our dequeue method throws an exception, we have to put this inside of a try catch. And while queue.size or get size, why isn't that having get size? Oh, we don't have a get size from here, so we have to add that. Public int get size, which will return simply the size. So while get size is greater than 0, we're just simply going to display out a dequeue method. Of course, we're going to have the exception here, and we'll just print the stack trace. Okay, so let's try and run this program. So we have our enqueue. This is our queue, which starts with 6 as the front, then 90, then 600, then 78, then 643. And then here is how we dequeued it. It's in the same order: 690, 678, and 643. So that is how you implement a very simple implementation, stack or no linked list implementation of a queue. I hope you have understood what you need to understand in this demonstration, and see you again next time.